Hello everyone, welcome back to another SLHL IB Chemistry 2025 spec video. Today we're going to be doing an introduction into covalent bonding. So let's see what actually is a covalent bond. So a covalent bond occurs when two or more atoms share with each other a pair of electrons. For example, hydrogen only has one shell. So what would happen here is that these two would come together to share their valence electrons to achieve a full outer shell, obeying the octet rule, which simply refers to the gain or loss of electrons to obtain full outer shells, achieve maximum stability. Exceptions to this octet rule include boron, which can create stable compounds with 3 valence electrons, such as boron trifluoride, as well as beryllium, which can do the same thing with only 2 valence electrons, creating beryllium fluoride. We also have dimers, such as aluminium chloride, which look like this. Which are stable despite our chlorines over here not having full outer shells. Now, a nice way to represent our different structures or bonds will be through the use of Lewis structures. When using Lewis structures, dashes will represent 2 electrons, whilst dots represent a single electron. So in our hydrogen example from earlier, this here would simply look like this. And with our boron, if we create a Lewis structure from this, we just have to add these lines over here to represent the lone pairs from fluorine, making it clear to us that fluorine is sharing an electron with boron, and boron is also sharing an electron with fluorine over here. Let's visualize that quite nicely, showing us that it does in fact not have that full outer shell. These structures which do not obey the octet rule are called electron deficient. And these, more oftentimes than not, are toxic. To identify the bond strengths of different covalent bonds, we simply have to look at how many pairs of electrons they share. So the more pairs that they share, the stronger the bond will be. And the shorter it will be as well. And this is due to the increased forces of electrostatic attraction between the negatively charged electrons and the positively charged nuclei, taking more energy to overcome. Now, last but not least for this video, we have coordination bonds. So these can be represented by an arrow with a flat base, and when we see this drawn in a Lewis structure, this simply tells us that both of the electrons within the shared electron pair are coming from one element or atom. This, for example, could look like this, where nitrogen on the right is giving both of its electrons to our boron on the left, because as we know, it only has 3 valence electrons, but can further fill out its shell. Now that is all for this video. Hope that it was helpful.